Welcome to this Future Brief Explainer. Today we're jumping straight into a very specific point in our near future, the year 2050. Now 2050 isn't just another year on the calendar. It's really shaping up to be a perfect storm, a convergence moment where our legacy institutional inertia is going to violently collide with exponential technological growth. We're basically looking at a fundamental structural transition across almost every single domain of human existence.
Now, just to anchor us in reality for a second, listen to what Rafael Mariano Grossi from the International Atomic Energy Agency recently said. Fusion energy is rapidly becoming a cornerstone of national energy strategies. The staggering reality here is that the sci-fi technologies we used to just dream about, infinite clean energy, thinking machines, autonomous flight, they aren't just whiteboard theories anymore. They're actively transitioning into industrial deployment right now.
The sheer scope of what we're looking at today is literally unprecedented. We're mapping out how 4 core domains of human life, the mind, our workforce, our movement, and our sustenance, are all barreling toward a singular convergence moment. Everything is connected. The massive advancements we're seeing in one field are actively providing the foundation for explosive growth in the others.
Chapter 1. AGI and the Mind, Bridging the Digital and the Physical.
Okay, so first, we've got to clearly separate our current reality from the speculative horizon. Right now, AI has some pretty significant gaps, specifically in visual reasoning, auditory processing, and crucially, a severe lack of continual learning and long-term memory. Our current systems just can't retain information across sessions the way a human mind does. But on the other side of that is the singularity, a hypothetical system combining human-level thinking with superhuman speed and near-perfect memory. To bridge that gap, we need at least one massive, meaningful breakthrough, particularly when it comes to long-term memory storage.
Because the stakes are so incredibly high, initiatives like AI 2050 are actively trying to solve what they call the hard problems in AI. They're tackling these exact scientific and technological limitations as we speak. We're talking about achieving true causal reasoning, developing safe multi-agent systems, and, maybe most importantly, ensuring alignment and humanistic ethics. They're working hard to eliminate information hazards, those weird hallucinations, and the toxicity we see in current outputs, all to ensure that advanced AI is actually safe and beneficial way before we hit that 2050 horizon.
$10 billion. Let that sink in. That is the massive commitment IBM alone is making to quantum computing, just to build the fault-tolerant systems required to actually process these future leaps in artificial intelligence. What we're witnessing is a massive mobilization of capital to physically build the infrastructure of the future mind.
Chapter 2. The New Workforce, the Era of Humanoid Robotics. So, as AI makes this jump from the digital realm into the physical world, you might be wondering, why humanoid robots, and why now? Well, it's a dire economic necessity. Working-age populations are projected to decline sharply across key industrial regions by 2050, and at the exact same time, human workers are increasingly unwilling to accept harsh production environments. We're facing a severe structural labor shortage, and humanoids are perfectly positioned as the ultimate catalyst to fill that void.
Now, this isn't going to happen overnight, right? We're looking at a staggered adoption timeline. While the technology is absolutely proving itself right now in pilot phases and early testing, projections note that adoption will actually be relatively slow until the mid-2030s. But then, as we hit the late 2030s and roll into the 2040s, we're going to see accelerating integration across both industrial and service environments, leading to some really complex scaling by 2050.
And the sheer scale of this shift, it's honestly hard to comprehend. Morgan Stanley projects that the humanoid robot market could reach an extraordinary $5 trillion by 2050. Because they have such broad utility across completely different industries and eventually our households, humanoids can eventually surpass automobiles in total units produced.
So, how exactly do we get to a $5 trillion market? It really comes down to manufacturing efficiencies and technological maturity. Projections are showing that these advancements could drive the average cost per humanoid unit down to just $25,000 by 2050. Think about that. That's the price of a standard car today. At that price point, widespread adoption in local businesses and your own home isn't just feasible, it's practically inevitable.
Chapter 3. The Future of Transport, Autonomy on Land and in the Air.
When we look down at terrestrial transport, we actually get a bit of a reality check. I know we've been promised fully self-driving private cars for years now, but the reality is that high software validation costs mean Level 4 private autonomy will likely remain a niche market by 2035, capturing only about 4% of sales. Instead, Level 2 advanced driver assistance is going to completely dominate the market for the next decade.
But here's the catch. While private ownership of fully autonomous cars is lagging, the commercial sector is a completely different story. Robotaxis are expected to scale rapidly across 40 to 80 global cities by 2035. Why? Because the operating costs for autonomous fleets are projected to absolutely plummet, from over $8 per mile down to just over $1 per mile. The logistics economics are simply too good to ignore.
All right, let's pivot to the skies. The eVTOL revolution, that's electric vertical takeoff and landing aircraft, relies on this incredible web of complex subsystems. There are over 1,000 different concepts emerging worldwide right now, and they rely on unbelievably advanced battery, propulsion, and autopilot subsystems to make urban air mobility a reality.
Provided that international regulators actually approve autonomous flight, the forecasts for 2050 are massive. We're looking at 45,000 global commercial eVTO deliveries and potentially 100,000 private, smaller eVTO vehicles. But the major hurdles aren't just building the aircraft themselves. It's navigating those highly complex certification pathways and building out the specialized charging infrastructure needed to keep them in the air.
Chapter 4. Fusion Energy and Food, Sustaining the 2050 Global Population. To power all of this new intelligence, the robotics, the movement, we basically need to completely overhaul how we sustain ourselves. Referring back to the IEA's World Fusion Outlook, we're seeing a really decisive shift. Fusion energy is officially entering a phase of real-world implementation. Major industries from automotive to aerospace and digital tech are actively incorporating fusion into their long-term energy portfolios to power the massive electrical grid we'll need for 2050. They're literally selecting sites and designing the first generation of power plants as we speak.
And hey, just as we're revolutionizing energy, we're doing the exact same thing to our food. Cultured, lab-grown meat takes a fraction of the time to grow and uses way fewer planetary resources. The market is poised for massive expansion, driven by intense food security pressures in the Asia-Pacific region and new regulatory clarity in North America. The business-to-business segment is expected to capture over 60% of the market by 2035. We're finally moving from pilot phases to scalable commercial deployment.
But getting cultured meat onto everyone's dinner plates means overcoming some pretty serious challenges first. We're talking about achieving real product quality, recreating complex meat structures, and bridging technical supply chain gaps. So what's the strategic solution? It's an aggressive race for cost reduction using innovative bioreactor designs, and forming deep alliances with top pharmaceutical and biotech firms to access the expertise needed to scale production affordably.
Chapter 5. Designing Tomorrow's Society, Governing the Convergence.
So let's put this all together. We've got AGI, a robotic workforce, autonomous skies, fusion power, and cultured food. How on earth do we actually govern this? To manage this incredible labor transition and prevent mass unemployment, international futurists from the Millennium Project have outlined some vital systemic actions. They suggest we absolutely must establish alternative cash flow projections for universal basic income. We have to fundamentally restructure our education system toward adaptive skills rather than rigid traditional professions. They even propose creating a global authority for AI alignment, kind of similar to the IAEA, and deploying personalized AI avatars that can match our individual skills with income opportunities worldwide via automated smart contracts.
Which brings us to a pretty stark warning. You see, the path of least resistance here is just maintaining the status quo. Basically, just using these revolutionary technologies to optimize our existing, outdated workflows. But if we allow our legacy institutional inertia to dictate our path, we risk severe social fragmentation. The alternative is doing the truly hard work to fundamentally reimagine human capability.
Which leaves us with one final, profound question to think about. As we rapidly approach 2050, will our legacy institutions adapt in time, or will we squander the greatest technological convergence in human history? It's a horizon that demands our attention right now. Thanks so much for joining this Future Brief Explainer today.